All right, hello everybody. Today we are going to be leaving equations behind and starting to work on inequalities. And today we are going to work on a couple of things. The first thing we're going to work on is we are going to do a quick review of graphing inequalities. On a number line. And then the second thing we're going to do is talk about another way to represent inequalities, which is called interval notation. Now, the interval notation part of this, I am fairly certain will be new for everybody. So the graphing part should be a review. The interval notation part should be a new concept. All right. So, first of all, let's take a moment here to talk about an inequality. All right, last week we reviewed solving multi-step equations, and we talked about the fact that an equation has to have an equal sign. And it expresses the idea that two quantities are equivalent to each other. They are the same. When we talk about an inequality, what we're talking about is a situation where two quantities are not the same. They are not equal to each other. And so you all will remember that when we start talking about inequalities, that we start to use different symbols. So we have less than or greater than. Those are both types of inequalities. And then we also have less than or equal to or greater than or equal to. So when we write inequalities, we're going to be expressing the idea that one quantity is less than the other or greater than the other, less than or equal to the other, or greater than or equal to the other. So those are the symbols that we'll start to see here. So let's start here by reviewing one way that you can represent an inequality. And that is to graph inequalities on a number line. All right, so let's start with this. Let's suppose that I have the inequality x is greater than 5. So I don't know exactly what x is, but I do know this based on this statement. X can be any number as long as it is greater than 5. So it could be 6, 7, 8, 9, 10. And on down the line, it could be 5.1, 5.01. So x in this situation can be any number that I can think of, provided that it is greater than 5. So one of the things that you all did in the past with this is you learned to take that inequality, x is greater than 5, and show it on a number line. So a number line gives us one way to represent an inequality. And when we make the number line, what we're trying to do is create an image, draw a picture of all the things that x is allowed to be. Now, my number line, I'm not going to make terribly detailed. I'm going to put 0 on there as kind of a reference point, and I know that 5 is to the right of 0, so I'm going to put my 5 on there. Now, to kind of review here with you, and I'm sure you're already kind of, the wheels are already turning here. One of the things that you all will remember about putting an inequality onto a number line is that you've got some decisions to make. Do I put an open circle on the number 5? Or do I put a filled in circle on the number 5? So an open or a closed circle on that number 5. And it all depends on whether x is allowed to be 5 or not. So when I look at this statement, is my x allowed to be the number 5? And the answer is no, because 5 is not greater than 5. So when I graph this inequality on my number line, the first thing I'm going to do is I'm going to put an open circle on that 5, because what I want to indicate is 5 is not a number that x is allowed to be. Okay, so you will remember that with the open circle, you use that for less than or greater than when x is not allowed to be equal to the number, and the filled in circle you use with less than or equal to, greater than or equal to, when x is allowed to be equal to that number. All right, now the other thing you will remember with this is that after we put our open or our closed circle on that 5, then what we want to do is shade either to the left of that 5 or shade to the right of that 5. And the purpose of the shading is to show us all of the other things that x can be. So this says that x can be any number greater than 5. So that would be 6, 6, and 7, and 8, and 9, and 10. So all of the numbers bigger than 5 are over here to the right of 5. So from that point, I would shade in the right side of my number line, and when I get to that arrow, I would shade that in as well, because what I want to show is that would continue on. So when I get my graph done, this perfectly represents what x is allowed to be according to that inequality over there. If I pick any number from this shaded area, it will fit what that inequality says. If I pick 6, 6 is greater than 5. If I pick 127, 127 is greater than 5. If I pick 5.5, 5.5 is greater than 5. So any number in this shaded area is an x value for this inequality. If I choose something from this non-shaded part, these are the numbers that do not fit this inequality. So 0, for example, 0 is not greater than 5. So the shaded area shows the inequality because it shows you all of the things that fit, all of the things that could be your x values. So I'm sure you all remember that. All right. Let's take a look at another one. Let's say we have x is less than or equal to a negative 3. Now again here, I'm not going to make my number line too terribly detailed. I'm going to put 0 on there for reference. Negative 3 I know would be to the left of 0, so I'm going to put negative 3 over there. Now, I want to represent this inequality with my number line. So the first question is, on negative 3, do I put an open circle or a closed circle? Well, this time it says that x is allowed to be equal to a negative 3. So this time I will fill in my circle on that negative 3 to show that that is actually one of the things that x can be. Now, shading. Do I shade to the left of negative 3 or to the right of negative 3? Well, I want my x's to be less than negative 3. So negative 4, negative 5, negative 6, negative 7, and so on. All of the numbers to the left are smaller. All of the numbers to the right are larger than negative 3. So I would start here at negative 3, would color in that side, shade in that side, and then when I get to the arrow, shade that in as well, because I would need to show that that keeps going. That keeps going. And how far does it keep going? Well, it keeps going forever. And in math, when we need to say something goes on forever, we use the idea of infinity. So this would actually be a negative infinity. A negative infinity, because we're going forever in that negative direction. So when we're graphing an inequality, when we're representing them using these number lines, our first decision is, do we put an open or a closed circle? So is that number allowed to be x or not? And then we put the shading in to show where the numbers that we are talking about would be. All right. Now, let me show you this. Now, just a quick reminder here. Notice that in this inequality, I am saying that 5 is greater than x. the other two inequalities that we've looked at like this one, have said what x is. That x is less than or equal to a negative 3. Well, wrong way. And then this one said that x is greater than 5. So I want to point out that with this one, it doesn't talk about x, it starts out talking about 5. It says that 5 is greater than x. Now, when you run across a problem like this, I'm going to put 0 on here for reference. 5 would be to the right of that. I think it's going to be a good idea for you to rewrite inequalities like this one so that the x comes first. We want this inequality to describe x in terms of that 5 instead of 5 in terms of that x. So if 5 is greater than x, then that means that x must be less than 5. If I were you on any problem where the number comes first and the variable comes second, I would rewrite those just so that I don't get confused about what I'm doing. So would this get an open or a closed circle on the 5? And the answer is it would get an open. This doesn't say that x can be equal to 5. And then we want to shade in all of the x's that are smaller than 5. Those are found to the left. So I would start out here at 5. I would shade all the way to the left. And then I would fill in my arrow to show that that keeps going. Now again, let me emphasize on this one that what you have just done here, the shaded area represents all of the things that x can be. So these are x values over here. So 0 is in that area. 5 is greater than 0. 0 is less than 5. I could pick negative 20, which would be over here somewhere. 5 is greater than negative 20. Negative 20 is less than 5. If I were to pick a number, though, from this unshaded area, like 10, 5 is not greater than 10. 10 is not less than 5. So these are the numbers that x can be over here. These are the numbers x can be. These are the numbers x cannot be. So that's what we're doing, is we're giving a picture of that inequality. So open or close circle and then put in the shading. If the variable doesn't come first, like we've got in this problem, then I would rewrite it. Now, let's move on to the second part of this. And this is new. So let's talk about interval notation. Interval notation is nothing more than another way to write an inequality. So the number line is a picture, and then the interval notation is another way to represent the inequality. Okay, now here's what you need to know about interval notation. When you do interval notation, you are going to use parentheses or brackets, and sometimes a combination of both. Now, here's what you need to know about this. So interval notation is going to write the inequality by using parentheses, brackets, or sometimes both. Parentheses mean an open circle. That means that number is not included. That number is not allowed to be an x value. Okay? Brackets are the same thing as a closed circle. So when we're doing interval notation, parentheses mean open circle, brackets mean closed circle. Now, let me show you how this works. All right, let's start out with an inequality here. Let's start out with x is greater than 1. I'm going to put that on a number line first. So 0 and then 1. Because this says that x is greater than 1, I know that x can't actually be 1. So that 1 is going to get an open circle. And then because this says that x needs to be greater than 1, I know that it has to be to the right of 1. So I am going to shade in all of these numbers over here, including this arrow. Now, here is the deal with taking my inequality that I started with up here. I've now changed that to a number line. And then the final thing that I want to do with this is I want to write it as an interval. So when I get finished, this inequality, this number line, and this interval will all represent the same thing. Now, here is the thing you need to understand. When you are writing intervals, you will always need two values. And those values come from this number line that we've made. So what I want you to do is come up here and focus your attention on this part of the number line that you have shaded in. Okay? 1, the number 1 is at one end of that shading. And then at this other end, you have an arrow, and that arrow is going to the right forever. So that would be a positive infinity. So this shaded region on the number line starts at positive 1, and it goes to a positive infinity. So when I write my interval, I want to focus on those two ends of that shaded area. My interval starts at 1 and goes to infinity. So you'll notice I'm going to write those two values down, and I'm going to put a comma in between them. So what I'm saying is the number line, this inequality, goes from a low value of 1 to a high value of infinity. And when you write these two numbers, they need to be in order, from the smallest number in the interval to the largest. 1 is smaller than infinity, so 1 goes first, infinity goes second. Now, what we're going to do from here is we are going to use parentheses and or brackets to show whether 1 is included in this set of numbers and whether infinity is included in this set of numbers. So here's the question. In this inequality up here, can x be equal to 1? Is 1 included as an x value? And the answer is no. There's this open circle here that says 1 is not included. X cannot actually be equal to 1. So for that reason, I've got this open circle here. With the 1, I'm going to put parentheses because x can't be equal to 1. Now, for the other end of this, we have infinity. And here's what we need to keep in mind about infinity. Infinity is not an exact amount. It doesn't have an exact numerical value. So x can't actually be equal to infinity because it's indefinite. We have no idea what it really is. So always with infinity, for that reason, you will use parentheses. Because whatever you imagine infinity to be, there's always something bigger. There's always something beyond it. There's infinity plus 1 or infinity plus infinity. So with infinity, you will always use parentheses because you can't be equal to infinity. So all three of the things that you see on your screen right now, x is greater than 1, the number line with an open circle on 1 and shading to the right, and this interval that goes from 1 to infinity, not including the 1. All three of these things are different ways to say the same thing. This interval is saying that x can be anything from 1 to positive infinity, but it doesn't include 1. So that's what this is saying. It can be anything from 1 to infinity, but it doesn't include 1. All right, hopefully that makes sense because that's new. And if it doesn't make sense, you will send me questions. You'll let me know. All right, let's try another one. Let's try x is less than or equal to a negative 2. So that is my inequality. On my number line, put my 0 with negative 2 to the left of that. All right, the first decision I need to make is open or close circle. This says that x can be equal to a negative 2. So negative 2 is included as an x value. So I'm going to fill in that circle. And then my x's need to be less than a negative 2. They need to be smaller. So I will go to the left and fill in my arrow to show that that would keep going. So there's a picture. There's another representation of all of the x's that are less than or equal to a negative 2. All right, now what we want to do is come down here and put this into the form of an interval. So remember, to write an interval, we're going to need two values. So you look at the two ends of your shading. One end of my shading is here, at negative 2. The other end of my shading is over here. And that's an arrow. That goes on. And it goes on in the negative direction forever. So my other value is going to be negative infinity. So when we're writing this interval, we look at the two ends of that shaded region. And for right now, one of your values should be either a positive infinity or a negative infinity. Now it won't stay that way, but right now for the moment, you should always have an infinity, positive or negative, and a number when you write your interval. Now, when I go to write my interval, I want to work left to right, lowest to highest. So out of these two values, negative infinity is the lowest. So I'm going to put negative infinity, comma, negative 2. So I'm saying the x values for this inequality range from a negative infinity all the way up to a negative 2. So x is somewhere between negative infinity and negative 2. Now we need to add our parentheses and or brackets to make this thing make sense. So the first thing is, can x actually be equal to a negative infinity? The answer is no, it can't be equal to that because negative infinity is not an exact amount. So that gets parentheses. Can't be equal to that. And then for negative 2, can x be equal to a negative 2? The answer is yes. So that closed circle is like a bracket. So when I look at this interval, it's letting me know that x is any number between negative infinity and negative 2, and the bracket says it includes that negative 2. So 3 different ways to show the same information. All right, let's do 4 is greater than x. So 0 and then 4. Now what I don't like about this inequality is it doesn't start out talking about x. It doesn't tell me about x. It tells me about 4. It tells me that 4 is bigger than x. So I'm going to make this thing tell me about x. If 4 is greater than x, then that means that x must be less than 4. So I want it to start out talking about x. Open or close circle. Open. Because x can't be equal to 4. And then if I want x to be less than 4, I would shade to the left. Color in the arrow to show that that would keep going. Now my interval. Remember, when I go to do the interval, I want to describe this shaded area that I have just graphed, and I want to look at the endpoints. So if you're thinking in terms of your geometry from last year, this would be a ray. This end of the ray is infinite, and it's on the negative end, so this would be a negative infinity. And this end of the ray is at 4. So when I write my interval, I'm going to use negative infinity and 4 to describe my numbers. Work smallest to largest, left to right. So we're going to do negative infinity, comma, 4. All of my x's are found between negative infinity and 4. Now, brackets or parentheses. Negative infinity has to be parentheses because x can't be equal to a negative infinity. And 4 also has to have parentheses because notice in this problem that x can't be equal to 4. This is that moment where I sure wish you all were sitting here in front of me, so if this is not making sense, you could ask me about it. So I'm counting on you. This is really the first new thing we've done so far. I'm counting on you to let me know if something's not making sense. All right, let's do one last problem. Let's do -3 is less than or equal to x. So for my number line, I want 0 on there. And then -3 would be to the left of that. Now, I bet you all could already guess I don't like this one because it doesn't start out talking about x. It starts out talking about -3. So if -3 is less than or equal to x, then that means x has to be greater than or equal to a -3. So we can see from this that -3 would get that filled in circle. And then x is greater, so I would go to the right and fill in the arrow on the right. Now, my interval. I need my two values. So I look at the endpoints of my ray that I've shaded in here. The first endpoint is at -3. The second end is over here on this arrow. That's going to the right forever, so it's on the positive side, so that would be a positive infinity. So when I describe my interval, I want to work left to right, smallest to largest, so I'm going to put that the interval is going to start at -3 and go to a positive infinity. Is -3 included? Can x be -3? And the answer is yes, so he gets a bracket. A bracket is like a closed circle. Can x be infinity? And the answer is no, because we don't know what infinity is. That's going to keep going, so we leave that open to let that keep going. All right, so hopefully I've made this clear enough that this inequality, this number line, this interval are just three different ways to say the same thing. The number line gives us a visual because we can look and see the shaded area, and we know any number we pick from that shaded area can be an x value. X can be all of these things in that shaded interval on the number line. And then when we write our interval notation, we're saying, okay, x can go from -3 to infinity, and it can include -3. Or if there were parentheses there, we would say it can't include -3. All right, so hopefully that makes sense. Today you are just going to practice graphing and writing intervals, and then tomorrow we'll actually put that to work in solving some inequalities. So if there are any questions whatsoever, be sure and let me know.